Welcome back to the Topic Class Revision Series. This is day 7 walkthrough and the topic today is percentages. So have your booklet ready. Hopefully you've had a chance to attempt the questions and let's get started. So for the first half of today's video, all of these questions are going to be non-calculator questions, and then we're going to move on and do the same topics but using a calculator. So the first question asks us to write 13 as a percentage of 20. Now what we're always going to do with this is we're going to start by writing as a fraction. So we've just got 13 over 20 as a fraction. Like we said yesterday in the fraction video, it's the first number is your numerator and the second number is your denominator. Now percentage or percent means out of 100. So we're going to make this into a fraction out of 100. So very simply, 20 times 5 is 100. So doing the same on the top, 13 times 5 is 65. Now we've got 65 out of 100, which is just 65%. So the answer to that one is 65%. Now the second one is very similar. We're writing 48 out of 60. Now we can't just go straight from 60 into 100. So instead what we're going to do is we're going to simplify this first. We're going to try and get it down maybe to 10 or to 20 or to something that gets us to 100. So we can do 10 in this case. So if we want to get it down to 10, we're dividing that by 6. So then 48 divided by 6, well 6 eighths are 48, so that's 8 out of 10. And then to scale this back up, again, percent means out of 100. So we want to get it to 100 by multiplying by 10. So 8 times 10 is 80. So we're finished there with 80 over 100, which is 80%. So again, when we want to write one number as a percentage of another, we write it as a fraction. We simplify it or we scale it up. We find the equivalent fraction, so it's out of 100. And then that's our percentage. So in this case, 65% and 80%. Now in this question, we're asked to find a percentage of an amount. So it says find 37% of 63. Now I've intentionally chosen numbers that are a little bit more challenging, but the reason being is you can get really difficult questions with this. You can get some really easy ones like 20% of a number, which is quite quick to do. But these ones are the ones that students normally stumble on. Now the method that I like to use is I do the percent multiplied by the amount, and then my second step, percent means out of 100, so we're going to finish by dividing by 100. So let's start with the percent by the amount. So we're doing 37 times 63, and again if you want to write those the other way around, that's absolutely fine too. So 3 times 7 is 21, so that's 1, carry my 2. 3 times 3 is 9, plus 2 is 11. Again, now moving on to the 6, put down your 0. 6 sevens are 42, so 2, carry your 4. 6 threes are 18, plus 4 is 22. If we add those together, we get 1, 3, 3, 2. So we've got 2,331. That's step 1. Then we're doing 2,331 divided by 100. And we get 23.31 as your answer. Okay, so that's our final answer. So sorry, that's not a percent. So our answer is 23.31. Okay, so remember, if we're doing a percentage by an amount, or finding a percentage of an amount, we multiply the percent by the amount, and then we divide by 100. Now these questions are asking us to increase by an amount or decrease an amount by a percentage. What I like to do is thinking this in a slightly different way. Increasing by 30% means that we want to finish with 130%. So we want to find 130% of 72. So we're going to do that in the same way we did the last question. We're going to do 130 multiplied by 72. So 2 times 0 is 0, 2 times 3 is 6, 2 times 1 is 2. Bring down your 0, 7 times 0 is 0, 7 threes are 21, 1 carry your 2, and then 7 times 1 is 7, plus 2 is 9. If we add those together, we get 0, 6, 3, 9. Okay, now what we do is 9,360 divided by 100, which gives us 93.6 or 93.60. Similar in the next one. In this case, we're decreasing 160 by 40%. So decrease by 40%. That means we're going to be left with 60%. So we're trying to find 60% of 160. So in the same sense, 160 times 60. Again, our first line are just zeros. Bring down your 0. And then 6 times 0 is 0. 6 times 6 is 36. 6 times 1 is 6 plus 3 is 9. So we get 9,600. And then we're doing 9,600 divided by 100, which just gives us 96. And we would have expected that because we're decreasing, we should end up with a smaller answer. So 96 is our final answer. So again, what we want to do when we're increasing or decreasing is find, well, what percentage will we end with? In the first case, in these questions, it was 130%. In the second case, it was 60%. And then just find that percentage using the method we saw in the last question. Now this question is slightly different. It looks very similar, but it's slightly different. It tells us the sale price, the reduced price, is a certain amount after being reduced by 20%. So because it was reduced by 20%, that means we finished with 80%. And it wants us to work out the original price. Because we're trying to find the original price or the price before the sale, this is what we call a reverse percentage. So for reverse percentages, we're going to say, well, that 80% that we know we finished with, that's equal to £56. Now the goal here is to get to 100%. Now we can't get straight from 80 to 100, similar to what we did with the fractions earlier. So let's go to an interim value. Let's go to 10%. 10% is usually a good one to go with. So to get from 80 to 10, we divide by 8. Okay, 8 sevens are 56, so therefore that's £7 when we divide by 8. And then to get from 10 to 100, we multiply by 10. 7 times 10 is just £70. So the original price was £70, and then on sale it's 56. So we would have expected that answer to be bigger, so we're probably correct here. The thing to remember is what we don't do is we don't find 20% and add it on. Okay, we find the percent like we did here with the 80, we find the percent we finished with, and then we use the method that we saw here. Now the next question says Kim has £1,000 in the bank account that earns 2% compound interest every year. Now compound interest is the difference here, and it asks us to then work out the amount after 2 years. What that means is we find 2% and then we add it on to our £1,000, and then we find 2% of our new amount and then we add it on. Now this is more often a calculator question than a non-calculator question, but it could come up as a non-calculator question, which is why we've got one example of those. So if we start, at the start we have £1,000. What we're going to do is we're going to find 2% of 1,000. Now I'm not going to go through the method to find that again, but 2% of 1,000 is £20. So therefore, after 1 year, or year 1, we've got £1,020. So after 1 year, we've added £20 on. Now in the second year, we're trying to find 2% again, but this time it's of £1,020. So in this case, 2% is £20 and 40p. So it's slightly more interest, and that's the value, that's the impact of compound interest. The interest will change every single year. So therefore in year 2, we have our year 1 value, so our 1,020, plus our new £20.40, which gives us an answer of £1,040 and 40p. So the value of our investment after 2 years is £1,040 and 40p. Okay, moving on to our final non-calculator question. It says a sofa costs £800. In the shop, they reduce the price by 40%. Well, that means we're going to be left with 60%. So we can put that there. And then it says on the final day of the sale, the sofa was reduced again by a further 20%. Okay, so that means we're going to be left in this case with 80%. So using that then, we want to find 60% of 800. And again, whichever method you use, okay, you can do that. But 60% of 800 is £480. So that's our sale price. And then our final reduction is a further 80% of, in this case, £480. So it's the new amount brought over. Now I can't do that in a quick way, so we'll go back to the method we saw in question 2. We do 480 times £80. So again, our first row are zeros, bring down your 0. 8 times 0 is 0, 8 8s are 64, 8 4s are 32, plus 6 is 38. Then we get 38400, which when we divide by 100 gives us £384. So 80% of 480 is £384, which is our final day price. And that's our answer. So we found our 60% or our 40% and took it away, and then we reduced it again by our 20% of our new amount, and we ended up with our final price of £384. Now the next set of questions are very similar to the first set, but the difference here is we're allowed to use a calculator, so it makes it a little bit easier for us. So in the same sense as before, we had 48 over 17. We start with a fraction. Now trying to get 17 to 100 is where the difficulty arises. So on a calculator paper, all we have to do is take that fraction and multiply it by 100. So anytime you want to convert a fraction to a percentage, you can just multiply it by 100. If we do that in our calculator, it gives us 282.35, and it continues on. Now rounding that to one decimal place as we were asked is 282.4. So our final answer, 282.4. In the second one, it asks us to find 52% of 3,156 and give your answer to two significant figures. Now, we could do, like we did in the last one, we multiply the amount by the percentage and then divide by 100. But instead what we're going to do is we're going to use what's called a multiplier. So we're going to convert this to a decimal by dividing by 100. So we get 0.52, and that's what we call our multiplier. Now that's quite useful because we're going to use that for all of our calculator methods. So we take our 3156 and we multiply it by 0.52, and that gives us an answer on our calculator of 1641.12, and that obviously continues. Then our answer to two significant figures. Well, two significant figures means we want 1, 2. So they're the two values we're going to use. So that's 1,600 as our final answer. Now this is where the way that we thought about the first round of questions is really going to help here. In this question, we're going to increase by 21%. That means we're finishing with 121%. Now we're going to make our multiplier. Remember, to get our multiplier, we're going to divide by 100. So that's 1.21. So very simply, to increase 183 by 21%, we do 183 multiplied by 1.21, which in our calculator gives us an answer of 221.43. Similar in the second question, we're going to decrease by 38%. So if we started with 100 and we take off 38%, we're left with 62%. Which again we know as a multiplier is 0.62 dividing by 100. And now because it's a multiplier, we multiply by it. So 4,500 multiplied by 0.62, and again remember we should expect a smaller answer here because we're decreasing, which we do get. We get 2,790. So with all of these questions we should be trying to figure out what is our multiplier, and once we've got our multiplier we just multiply by it. And that's going to allow us to do these calculations much easier using a calculator. Now this topic we didn't actually do in the non-calculator version. It's usually seen in a calculator topic, but the same method would apply. So as the population of Ormore was 4,799 in 2011, in 2022 the population risen to 5,819, and it asks to calculate the percentage increase. Now to calculate that, we just do the change over the original, and we multiply that by 100. That's the formula we need to remember. So change over original times 100. So the change in this case is 5,819 minus 4,799, which gives us 1,020. And now we can just sub that into our formula. 1,020 over the original population, which is 4799, multiplied by 100, and that gives us an answer when we plug it into our calculator of 21.25, etc. So therefore, if we go to one decimal place, 21.3%. Okay, so remember, when we're finding a percentage increase or a percentage decrease, we do the change over the original and multiply it by 100. Now this question again is our reverse percentages. We've got a value here including VAT, and we want to find it without the VAT. So this is our reverse percentage. And we're going to do this in a similar way to we did the last one, but again we're going to use our multipliers. So 20% including VAT, that's an increase of 20%, so that means we finish with 120%, or as a multiplier 1.2 or 1.20. Now with reverse percentages, because we're trying to go backwards, we do the opposite with our multiplier. So in this case we do 1750, and because we're going backwards we divide by that multiplier of 1.2. So we do 1750 divided by 1.2 in our calculator, and that gives us 14.583, etc. So our correct answer is 14.58, so £14.58. Now we have to be careful here. The key thing here is why 2 decimal places? And the very simple answer is money. Money is always to 2 decimal places or 0 decimal places. Okay, it has to be 2 decimal places or 0 decimal places. We don't have 14.6 pounds. Okay, we've got £14.58, or we could round it to £15. But obviously we want to keep the accuracy here, so we use the pence as well. Okay, so remember, with our reverse percentages, we do the same thing. We find our normal multiplier, and then we just divide by it to find our original amount. Now looking again at compound interest, first one here we got is 4%, so that means we finish with 104%, which is a multiplier of 1.04. And then in this case 2%, which is 102%, or as a multiplier 1.02. So it says Ross has £3,500 in his bank account that earns 4% interest for the first year and then 2% every year after that. And we want to work out how much money will be in the account after 4 years. Well, we're going to first do our 1.04, and that's for 1 year, so we can use it at the power of 1. We don't have to write the power, but we can do that there. And then for the second one, we're doing 1.02. That's for 3 years, so we can write it to the power of 3. And we can see that if we add the 1 and the 3, the powers, that gives us our 4 in total. So we can do this quickly in one calculation in our calculator, type all of that in, and that's going to give us an answer of £3,862.80. Okay, there's no rounding required here. That's what it stops at, so we know that we're correct. So again, we find each of our multipliers, we raise it to the power for the number of times we're going to use it or the number of years, and then multiply it all in one go. We can use varied ones together, and that gives us our answer. So £3,862.80. Now the final question is an interesting one, because this is the one that tends to catch people out. Okay, so it says, if I invest money that earns compound interest at 5% per year, how many years will it take me to double my money? So we've got 2 options here, and I'm going to show you 2 different methods to do this. So method 1, and again in an exam you'd only do one of the methods. What we're going to do is pick an amount. Okay, what I mean by that is we're just going to pick an amount of money. So I like to just use £100. Okay, it's nice and easy. Now 5% I know is a multiplier of 1.05. We've looked at how to do those. And we're doing 100 times 1.05 to the power of something. And we need to find the number that gets us to £200. Why 200? Because we want to double our money. And in our calculator, we're just going to try different numbers in here. Now, you don't have to write down every single value. Okay, but if we start by working on a couple of them, so I'll do a couple of here. So we'll have, let's say, 100 times 1.05 to the power of 5. If we did that, that would give us £127.63. Okay, that's too small, and it's still quite a bit away, so let's go a bit higher. Let's do 100 times 1.05 to the power of 10. If we do that, that gives us £162.89. Okay, we're getting closer, but still quite a bit away. Let's jump by another 5. So 100 times 1.05 to the power of 15 gives us £207.89. So that one's too big, but it's quite close. So let's check 14. So 1.05 to the power of 14. And that gives us an answer of £197.99. So at some point between year 14 and year 15, we crossed that threshold of £200, this threshold we're trying to figure out here. So with that in mind, interest is always added at the end of the year. So therefore we would say the answer to our question is 15 years. Now, what must we write? Do we need to write all of that down? Absolutely not. All we need to write down is the year that's too small and the year that's too big. And then the decision is usually the year that's too big, but it depends on the question. It might say, what's the maximum amount of time until my money is doubled? Then we would use 14, okay? Or we would try and work it out in a different way. So depending on the context, that might vary. Now method 2 is pretty much the same, but we just work with our multipliers. And instead of using an amount, we would just do 1.05 to the power of something to give me 2. Again, if we tried all the same things, but we'd eventually get to 1.05 to the power of 14 gives us 1.9799, and 1.05 to the power of 15 gives us 2.0789. And we can see obviously 14, 15, so again will be 15 years. So we don't have to pick an amount, we can just use our multipliers like we did over here. However, often students prefer to use the context of an amount of money, and it just makes a little bit more sense. So hopefully you found that one helpful. Now to finish, I want to take one more look at this final question, because there is one other way to do this, and this is the proper mathematical way to do it. However, we don't use this in GCSE because it's not part of the curriculum. However, it's just more of an interesting thing to be aware of. If we have a situation where we have a to the power of x equals b, so they're just some values, we've got these things called logs, and in these cases that a is what we call our base, the x is what we call our index, and our b for this argument we're going to call our solution. Now the inverse of an indice is a log, so we would say log to the base a of b gives us x. What that means is log to the base, so this is our base here, of the solution, so the answer we're trying to get to, gives us our index. So what does that mean for this question? Well, we had 1.05 to the power of something gives us 2. Now, we're not going to use that box anymore. We're not going to say the power of something. Okay, we're going to use something that's a bit more useful. We're going to say it's the power of x. Using our idea of logs, that will be log to the base 1.05 of 2 gives us x. Now, on your calculator, you'll find a button that says this, so it looks slightly different, but it's usually on your calculator. You can write log, it'll say log, and then a little square there, and a big square there. That's the one where you can pick your custom base. Okay. The reason this is useful is because if you then put that into your calculator, it gives you x equals 14.2067. So it's a little bit more than 14 years. So that tells us it must be 15 years. Because as I said, interest doesn't get added in the middle of the year, it gets added at the end of the year. So 14 years is too small, so it must be 15 years is your answer. Again, not really as relevant for GCSE Maths. You probably could use it and you'd probably still get the marks, but again, it was just an interesting idea of surely there's a better way than the method we've used, and there is mathematically, and it's using logs. As always, thank you for watching the video. I really hope you found it useful, and I'll see you tomorrow for the next video.